have fields of science as their expertise, they think it's a scientific fact that evolution happens. Dogs came from an amoeba. They just don't understand how I can't see that. But you do believe dogs came from an amoeba if you go back long enough. I'll give you all the time you want. You can have trillions, quadrillions of years. Ultimately, to summarize it down into one sentence, I'm assuming I can speak for you and say dogs came from an amoeba-like creature, a single-cell creature. Is that what you believe?
Well, not an amoeba. I can.
A single-cell creature.
I don't think that we should go into the details of the evolution of the early evolution of animals, but it has actually been shown with some confidence that a certain group of unicellular eukaryotes are on the cellular level are almost identical to the cells of a sponge. They look almost the same. They have almost the same function. The basic difference is that in the sponge, all these different cells are grouped together in a single organism, and this unicellular organism is of course unicellular. Though once in a while it also forms a colony of cells that works like a very simple kind of sponge. So actually that has been shown in some details how the very very early evolution of animals has been going on. But never mind. Do you have any?
Well, I just want to point out to the audience that you evaded the question. I said, do you?
Did you ask me if we evolved from amoeba? And I answered.
Do you believe, just very simple, yes or no, do you believe animals, multi-celled animals, like humans, do you believe humans evolve from a single-celled creature, whether it's an amoeba or not, a single-celled creature, in any amount of time? Yes or no? Do you believe that?
Yes. Yes.
Yes. Okay, good. And I point out, you are welcome to believe that. But that's not observable science. We observe amoebas and single-celled creatures multiplying all the time, in a very short generational time for most of them, and we never observe them producing anything else. So if you wish to...
Hey, can I show you?
Sure, please do.
Yeah. See, it's a bit down here. Here it is. Yeah, here it is. Yes, this one. Hey, what do we have here? We have two single-cellular organisms, one called Paramecium and one called Chlamydomonas. Chlamydomonas is the little green one with the two antennae, and the other one is the fluffy one. The fluffy one to the left is eating the little green one, but it can only eat it if it is unicellular. And it always is unicellular in nature. It has never been observed to form colonies in nature. But if you put these two together, then Paramecium starts eating the little green one, which is actually an algae. And as a response to that, for the first time in history, it forms colonies. And those colonies are actually a little different when you repeat the process, which I have illustrated to the right. The bluish, I don't know if you can see it in the middle, the B column. There is a kind of bluish shadow around some of the cells, and that's one way of producing a multicellular organism. That single cells are grouped together, and there's a common membrane or the mutual membrane around all of them, and then they release single cell individuals which form new colonies in the same way. Or the colonies can be constructed by the single cells kind of gluing together and then releasing single cells that grow in the same way and form colonies. So this is the very, very first step from a single cell organism towards a multicellular organism, that the cells do not leave each other when the cell division is finished. They kind of glue together and form a colony. And the next one is going a step further. This is
let's go back to that one if we could. Go back to that slide. Are you saying that a colony of cells is equivalent to an organism like a dog or a human, which has obviously maybe 100 trillion cells in a human?
No.
They're working as organs, not as colonies. Now, this is very different. I think they're confused about a colony getting together for protection or for food production or something. We have all kinds of farmers get together in one community and have a colony of people. We had the American colonies, but they didn't ever fuse to become one human. They're still individual humans, and these are still individual cells. The fact that you have a colony of cells cooperating in a common goal, protection from the paramecium in this case, is not evidence that they can become a single organism, like the humans are still producing humans, even though they have colonized together thousands of times. So I think you're very misleading in your illustration here. If you're misleading the audience to think that this is a step toward multicellular organisms, no, this is a multicellular colony. Please don't confuse the two. This is not evidence for evolution.
But what would the very first step from a unicellular organism to the multicellular organism? It had to be a colony of identical cells. It had to be the first step. What other step could be the first step?
That's a great point, Stefan. This is evidence that you have great faith that something did happen, and you're looking desperately for the steps of how it happened. But that's not science.
Looking right at the first step.
No, there are three things.
And if you will allow me to show the next one, I'm looking right at the next step.
Well, let me finish with this one. Let me finish with this one first. I don't want the audience to think that you're correct on this one. There are single-celled organisms, millions of them. There are single-celled organisms that work as colonies. That's very different. They're very different than a multicellular organism. You're assuming the colony is a step between the two. I completely disagree. This has not been demonstrated in any laboratory anywhere because you have to get a huge amount of new information. Each one of those cells that came into that colony had a gene code to make a cell just like itself, or with a few minor variations. None of these cells in this contain the genetic information to make hearts, livers, organs, skin, toenails, hair, teeth, eyeballs. Okay, and they're never going to get it. There's no new information in that colony. There's a new cooperation, but there's no new information, no new genetic information. So you're deceiving people to say that that would be a step to go from single cell to a multi-celled organism. The colony is totally separate, unrelated. That's a rabbit trail you're leading people down. Go ahead to step 2, but I'm going to strongly disagree on your step 1.
Okay, but if there is no new genetic information, why do they stick together? What makes them stick together? What makes them stick together if not a change in the genetics?
Was there a change in the genetics?
If the genetics is still exactly the same, then why do they stick together?
It was in their genetics all along to stick together as needed.
No, it wasn't. No, Mr. Hovind, it wasn't. It has never been seen before. Never.
Has anybody seen new genetic information that tells these single cells to join together to a colony? There are people all over the world who are individualists, like Daniel Boone, go out across the wilderness by yourself. And yet most of the people want to get together into a colony, like the New England colonies that came over here mostly from Europe. But they're still individual human beings. The human beings never grew together to be one 5,000-ton animal or creature. They're always individuals in a colony cooperating. All you've demonstrated is the cells can cooperate for a common goal so they don't get eaten by the paramecium. That's cooperation. That's not accumulation of new information.
But why do they cooperate if they still are identical to the original one cell organism?
Yeah, so they don't get eaten. Why do people colonize and get together so the enemy doesn't in a wartime? Why do they form armies? An army is not a single unit. It's not a one organism. It's a group of individual humans.
So what you are saying is that these single-celled algae has some kind of individual goal that we don't want to be eaten, so let's cling together.
Oh,
That's nonsense.
I have no idea.
You are constantly comparing them with humans.
I have no idea what they're thinking. But
they don't have a goal. They don't have a brain.
Right.
All they have is the genetics.
You have not demonstrated that there's any new genetic information, and you've not demonstrated that this is a step toward a multicellular organism like a dog or a human. That's a colony. Don't confuse people with trying to say this is similar. It's not similar. This is not a step. You have no link. Where are the two-celled organisms in anywhere in biology? You have a master's in biology and a PhD in botany. Where are the 2 or 3 or 4-celled? There are none. The closest we get is a colony of maybe 20 cells cooperating together for some reason. But again, each cell contains the same original genetic code. And I would say in a court of law, Your Honor, you cannot demonstrate that the individual cells don't already have something in their gene code to say, oh, if we're getting threatened, join together. Just like people, when they feel threatened, they go huddle together and make themselves an army or a colony or a kingdom. That's not evidence for evolution, Stefan. Stop deceiving people. Go ahead, step 2.
I don't. These single-celled organisms don't know that they are chosen, that they are going to be prey for this predator, not before they are eaten. They are swimming happily around in the water, and then suddenly, shoop, they are gone. They are not warned in any way. It's not that they can foresee that, oh, we are going to be eaten because this paramecium is swimming around here, so we have to do something. That's not what's happening. Either they are eaten or they are not eaten, and that's it.
Let's take one topic at a time. So, does the single-celled algae have an escape mechanism? Does it have a mechanism to sense danger? Why does it flee? When the paramecium comes to the algae, does it lay there and let it be eaten, or does it try to evade being eaten in any way? Are those 2 little hairs on the algae, are they actually a flagellated paramecium, flagellum that can spin, that allow it to swim away? I think you'll notice I
don't know if it has any of the paramecium.
Get a microscope that can view down to single-celled organisms. If an enemy comes in, almost all single-celled organisms have A, a method of detecting their enemy, and B, a method of trying to evade their enemy. None of them lay there and get eaten, or they would go extinct. All of them have some method of protection. So you're saying they just colonize for no reason. No, I think maybe they have a reason. What they think, I don't know if paramecium or these creatures think at all, but apparently they do have some kind of mechanism already built in the gene code to detect a predator or a danger and to evade it. I think it's been demonstrated thousands of times that some can even change their coating on the outside if a particular chemical is present in their environment. They will learn to protect themselves by developing a shield around them. This is not adding new information. This is a selection of information already existing in the gene code. So to go from a single cell to a colony is not going to help your theory. But I know you believe it and you want to believe it. But it's not science. This is your religion. I'll stick by that. Anyway, so you think the colonies are is a step between single cell and multi-cell. I completely object. That is not correct. But go ahead. What's your step 2 going to be?
Well, first, I have to stress that this has been repeated several times, and at least some different mechanisms has turned up. The column B and C shows 2 different ways that these cells protect themselves. So this points rather to new genetic information than to some pre-existing mechanism. But this step 2, the natural step 2 in the course from a single-celled organism to a real multicellular organism would be first to form a colony and then to initiate some kind of cell differentiation. And the very first steps towards cell differentiation is illustrated here. I have to explain what's going on. They have selected for colonization by by growing these fungi, it is, in water that is not shaken, so that the cells would settle, and colonies of cells would settle faster than single cells. And by sucking up the cells that were in the bottom of this this tube, they got an enrichment of colonies of cells. And when they observed them, they observed something quite extraordinary, because they actually observed cell differentiation. They were able to stain these cells in various ways, and by doing that, they could see that the cells were actually behaving differently. It is illustrated here by some of them being blue and some of them being green. And it turned out that the cells that were different from the majority of cells actually were those that later died and caused the colony to separate into several colonies. So here we have the first step is colonization from single cells to colonies. The next step would be the very first initial steps towards a cell differentiation. And what we see here is actually cell differentiation. Some cells die, which helps the colony of cells to divide into separate colonies. And, and this is not just a second. And this is actually beneficial for the cell colony, because a large colony of cells would the nutritional supply to the cells in the middle of the colony would be less efficient than if the cell colony divide into separate colonies and then keep on growing. And that is what we see. And what the major point here is that they could identify the cells that later would cause the colony to separate into separate colonies. They could identify them several cell generations before it actually happened.
Okay, let me give my answer to that. Obviously, if there's a cluster of cells that have colonized, the ones in the center are going to get less nutrients, we would assume, because they have less contact with their environment. They're surrounded by other cells and they can't eat, sleep, breathe, or poop. So, of course, that's the place where the colony is going to separate. Those are the cells that are going to die and no longer cling to other cells. But again, I would point out that cells getting together and colonizing, and then even differentiating, whereas different ones have different functions in the colony. In the American colonies, people came over, they settled, and very soon after they got the basic needs met, some became farmers, some became bankers, some became cooks. They had different activities, different specialties that they would, but they're still individual humans. They never merged into one 10,000-ton human being. They were each individual people in a colony. All you've demonstrated here is the same thing. A group of cells can get together, and maybe one is better at taking in a certain substance that the colony needs for survival. One may be better for defense, but they're still individuals, and I would point out that you've not demonstrated that this could not already be in the gene code. There are individuals who can live completely on their own, completely. They can go out in the woods and survive on roots and berries and catch animals, but if they join in with a group of other people, pretty soon they take on their specialty of maybe they're the marksman shooting game or the gardener raising crops. They're capable of living on their own, but they're also capable of living together with others. What you've demonstrated here is single-cell organisms are capable of living on their own, or they're capable of living in a colony. And if they get too big of a colony, the ones in the middle are going to die and hence break the colony at that point. So yes, I would think that's probably scientific and logical that you could look at a colony and say, that one's going to die and this is where it's going to split. This is not evolution. This is no help for your theory whatsoever.
Oh yes, because they could identify the cells long before the colony actually grows so big that the cells were in any problem of nutrient supply. But I think we should leave that. We will not agree on this. So we can just agree on disagree.